Last but not least, here's a chance to test yourselves on this practice with a slightly more complicated function. Notice there's a discontinuity here. So we're going to call this f of x this time, and we're going to go back to the terminology of capital F of x. And just ask yourself, which of these graphs down here could be the antiderivative of the little f graph? We'll pause for a few seconds and then take a look. Okay. First thing to notice, again, is that connection of areas or integrals translating into changes of f. So on this region, we have a negative integral, and so the function has to go down between 0 and 1. Capital F of x has to go down between 0 and 1. That rules out c immediately. C is starting to go up right off the bat. Next point is that we have the y values on the graph we're given, translates to slopes, and we have at x equals 1 a y value in this graph of 0, which means a slope of 0 at x equals 1, and that actually satisfies all of them. So a slope equals 0 at x equals 1, that's checked off all of them. What can we look at next? Well, from 1 to 4, on this range here, the y values are all positive, and that means from x equals 1 to 4, the slopes have to be positive. From 1 to 4, the slopes are all positive. 1 to 4, slopes are all positive. 1 to 4, slopes are all positive. Okay, we still have that. All right, finally this last part. When we reach 4 and go to 5, what's going to happen? Well, again, we're going to have negative y values, or a region, an integral region here that's below the x-axis, negative. So we'll have negative y values on the original graph. The antiderivative will be negative then. We'll have negative slopes. So the slopes will be negative for x equals 1, 4 to 5. That's true for this function. Good. It's not true for this one, so we can rule out b finally, but it is true for this one. Okay. Last but not least then, which of these two graphs is the right one? Well, we can actually look at the shapes and go, well, they're actually very, very similar shapes. The only distinguishing feature is the scale. This interval, on this interval, this graph goes down by a full 1 unit. On this graph, this function goes down by 0.5. We have information about that. This integral value, or area, is negative 0.5. So the function should drop by 0.5, going from x equals 0 to x equals 1. This one has a change in f of negative 1. That's not what we need. So the final answer, the correct graph, must be D. And we can reassure ourselves of that as well. From 1 to 4, we should go up by 1 unit, 2 units, 2.5. Half, 1, 2. There we go. That's a 2.5 gap. And on the last little interval, we should also go down by 0.5. And we see that as well. So all the changes in values here match up with the areas in the graph of the original function.